Okay, last part of chapter 9, if you look at the last page in your notes, we're talking about what we call lever systems. Now, we've talked a lot about movement, and there are a lot of things that go into movement, and we're really not done with movement because that's the majority of what the body does. But if we think of movement and changing our position in space, a lot of different things go into it. Bone. We said bones are levers that create movement. Joints. The type of movement available is based on the shape of that epiphysis, what the end of that joint looks like. Is it a round ball like the shoulder or hip? Is it some kind of convex-concave relationship like at the elbow? Is it a pivot? The shape of the bone is certainly going to dictate how we move. But we can't think about movement without considering muscle, and specifically with muscle, how does the muscle attach to the bone? Where does the muscle attach to the bone? And so when we look at these things that we call lever systems, we're combining the bone, the muscle attachment, and the location of the joint in dictating kind of how we move or what the characteristic or quality of that movement is. So we're taking a principle of physics, lever system, and we're going to apply it to movement. So if we look at any lever system, if you will, it has four principal components. A lever, which is a rigid bar. Now, in the body, who is the rigid bar? Bone. The fulcrum. The fulcrum is going to be the point of movement. Well, if we think about where is movement occurring in the body, the fulcrum is the joint. Effort. Effort is producing the movement, creating the movement. So for our purposes, it's muscle, but specifically, it's the location of the muscle attachment. Where is the muscle specifically attaching to the bone? And then finally, load. Load is going to be resistance. It's going to be the weight of what we're trying to move. So for our purposes, we could just say, weight is coming from gravity, but it's the weight of the arm, or it's the weight of the markers that I'm trying to move in my hand. Whatever it is, it's our resistance. It's our load. So when we look at the different types of lever systems, we're going to consider the relationship of the fulcrum, the effort, and the load on our lever. And so we're going to look at three different types of levers: a first class, a second class, and a third class. And again, your last page of notes, we've got areas for these three different types of lever systems, and so we're going to compare and contrast those. Okay, so we've said that we've got three different types of lever systems: first class, second class, third class. For all of these lever systems, we have the lever itself, which is a rigid bar, we said, which in the case of the human body is bone. So we've got long black lines indicating our lever. Now, we said there are three other players in this game. We said that we've got a fulcrum, we have effort, and we have load. And so we have to insert those three things into our lever, if you will. So the first thing that we're going to look at is the first class lever. And in the first class lever, we'll use green for the fulcrum. The fulcrum is going to be in the middle. The fulcrum is in between our effort and our load. So in the real world, where do we find fulcrums in between effort and load? Any playground across America, depending on where you're from. Teeter-totter or seesaw. One person on one side is providing the effort, person on the other side of the seesaw or teeter-totter is the load, and so that fulcrum, that pivot is in the middle. We do not have many first-class levers in the body. And the best example of a first-class lever in the body is looking up toward the ceiling. So if you look up toward the ceiling, the fulcrum, the pivot, would be those occipital condyles sitting right on the atlas, right on that first cervical vertebrae. The effort is coming from all of those cervical extensor muscles in the back of your neck. And then you'll have to trust me on this one, but the center of gravity for your head is actually located just anterior to the joint. And so load, weight of the head on one side, effort, muscle contraction, muscle attachment on the other side, and the joint directly in the middle. First class lever. Now, when we start to look at our second and third class levers, here's the way I remember it. You've got three players in the game. Effort, fulcrum, load. Everybody has a chance to be in the middle. Best way to think of it. First class fulcrum got to be in the middle. So in the second class lever, we're going to let load be in the middle. So load is now in the middle. I'm going to put my fulcrum on one side, and I'm going to still keep effort over here on the other side. So now I've got a situation, we've just kind of flipped the players in the game, load's in the middle. Real world. I don't have one with me, but this is a wheelbarrow. Fulcrum would be the axis, the axle of the wheel. Load, the dirt, the bricks, whatever it is that you put in the barrow or the bucket of the wheelbarrow. And then effort would be you picking up the handles at the other end. And so that is a second class lever. Body, again, not very many of them. Best example, heel raise. I'm raising up on my toes. How does this work? How does it fit? Well, what's the fulcrum? Kind of the ball of the foot. Okay, that's where I'm raising up on my toes. Load, body weight, plus I'm holding 4 markers in my hand, so I'm also moving the markers. Effort, gastrocnemius and soleus muscles, your calf muscles. And so the load, the center of gravity, the weight of your body, is kind of over the middle of the foot. Joints on one side, effort is on the other side. So that becomes a second class lever. And then the third class lever, who hasn't been in the middle yet? Effort. And so we're going to put load on one side and our fulcrum on the other side. So now in this third class lever, this is what we typically find in the body. This is the primary arrangement when we think about moving our extremities. Joint, muscle attachment, effort, somewhere in the middle, load, typically out at the far side. So the best example of this, let's do that curl that we were talking about earlier. If I'm going to stand here and do a curl, fulcrum, trochlea of the humerus, trochlear notch of the ulna. Effort, muscle attachment, the bicep muscle, the brachialis muscle attached to the radius and the ulna, just on this side of the joint. Load, well, I've got 4 markers in my hand. I've got 15 pounds in my hand, 20 pounds in my hand, whatever it is. But that load is located way out here. The muscle attachment is in between. And so that becomes a third class lever. Everybody's had a chance to be in the middle. Now, there's an important thing that we have to recognize when we think of especially our second and our third class lever, and that is what we refer to as a mechanical advantage or a mechanical disadvantage. There's a very big difference between our second and our third class lever. If we look at both of these, look at the second class lever. Look at how close the load is to the fulcrum compared to effort. to the fulcrum. The load is significantly closer. Look in the third class lever. Who's closer to the fulcrum? Well, effort is now much closer than load. And that's significant. And the reason that that is significant is because this distance is going to determine, am I at a mechanical advantage or am I at a mechanical disadvantage? Now, what do we mean by that? Well, let's compare our two movements. Second class level. Load's closer. What was our human example of a second class lever? Heel raise. If I'm doing a heel raise, I am at what we refer to as a mechanical advantage. How far am I moving? Not very far, a few inches. How much weight am I moving? Weight of my body, plus 4 markers. I could put a 45-pound bar on my back, and I could still do a heel raise. I could put 100 pounds on my back. I could still do a heel raise. I can move, because I'm at an advantage, a lot of resistance. The trade-off is I can't move it very far. Third class lever. I am at what we refer to as a disadvantage. Why? Because now my load is really far away from my fulcrum. It's a great distance. So the trade-off is, third class lever, we said that that is a curl. Well, how far am I moving that marker? I could move it from my side to my shoulder. I could move it from my side over my head. I can move a great distance. What's the trade-off? I can't move much weight. So again, we've always talked about the free lunch is never free. There's always some kind of a trade-off when we're talking about these things in the human body. If I gain something, I usually have to give something up. Well, when we look at our lever systems, if I gain strength, if I'm in an advantage, my trade-off is range of motion. Yeah, I can move my body weight 3 inches. If I'm at a disadvantage, I can move a great range of motion, but I'm not lifting 200 pounds over my head. So your homework assignment to recognize advantage and disadvantage is go to the gym and do a heel raise and determine how much weight you can do a heel raise with. Your body weight, let's say 150 pounds, plus maybe you put another 150 pounds on your back and you do a heel raise. We've established you can move 300 pounds 3 inches. Now, take that bar on the floor and put that 300 pounds on it and do a curl. And the obvious answer is you can't. Why not? Because in the third class lever system, we're at a disadvantage. The load is too far away from the fulcrum. In real life, think about picking up a heavy box. If you're going to pick up something that's heavy, what do they tell you to do to protect your back? Keep it real close to the center of gravity of your body. Keep it in real tight. I can't lift that heavy box way out here because I'm at a disadvantage. The closer I can get that load to the fulcrum, the more efficient I'm going to be, the stronger I'm going to be, and the more protected you're going to be if you start to think about injury. That's not really our intent, but they do all kind of go hand in hand. So that's our lever systems. First, second, third. The first class lever, who's at an advantage or disadvantage? Depends on where the fulcrum is located. If we put it right in the middle, we're kind of equal. Those two kids on the teeter-totter are all going to go the same height. But if we were to move the fulcrum toward the load, now the load's closer. That's going to put me at a mechanical advantage. Think of a furniture mover, one of those tools that would allow you to lift a really big heavy piece of furniture up. Yeah, I can lift that 200-pound armoire half an inch. Not very high. If I move the fulcrum to the other end, Now I can move that load a great distance. Think of a catapult. But I'm at a disadvantage. I can move it a great distance, but I can't put a whole lot of load out here. So those are the lever systems. And again, we're talking about fulcrums, joints, and when we think of effort, where is the muscle attaching to the bone relative to the joint position in the body? So that's it. That's lever systems.